right, so we are at our third stop, our third Pinacea tree, so still in the same family of Pinacea, but what you're looking at here is called an Abies concolor, which Abies stands for fir, so this is a white fir tree. We do not know where the plaque is on this tree. I think as the trees grow, sometimes the plaques fall off or are absorbed into the bark, so I'm not going to dig through there to find it, but just trust me, this is an Abies concolor, a white fir tree, and its needles are very, very different from the other ones that we saw. So like a pine, like our first tree that we looked at, they're relatively long, 3 to 4 inches, but unlike them, they're flat. So I don't know, I'm trying to roll it between my fingers and it's not rolling. I don't know if you can see that, but we have P for pine tree is for our packet. Our S on our spruce tree is for short, spiky, and spherical. On a fir tree, we think of flat. The needles are flat, and if you ever pick up a needle from a fir tree, you'll know exactly what I'm saying. We also look at the branches, so if you pull off a few of these needles from the branch, it doesn't have that little projection that you have on a spruce, and they're not bound by fascicles either, so it's relatively smooth after you pluck the branches, so it binds differently to the branch. This tree is super well maintained by DU's campus grounds people, so I cannot find a cone for you, but I can describe them to you. They're relatively longer than the other ones that we saw. They're usually a bit more colorful, sometimes like a bluish color, and interestingly, where the pine cones on the spruce and the pine trees hang down, they often go up. They stretch up into this, like they would sit right here as opposed to hanging down below. So that's the primary differences between the cones in this particular tree. Okay, so we have talked about 3 different trees, all within the same family, the Pinacea family. And they're in the same family because they share a lot of the same characteristics. They're somewhat related, right? So all 3 of these trees, you will notice we talked about their needles as opposed to leaves. And so these trees have these needles year long. They're always green. And so we call that, the one characteristic that defines these trees, is called an evergreen. They're evergreen. So needles that last all year long as opposed to like a maple or an oak, which drops their leaves in the fall. The other primary commonality between these 3 trees and within the Pinacea family is what we've pointed out. I don't have one in my hand right now, but the cones. So all 3 of these trees have cones, which help to spread their seeds. And the fact that they have cones, we give a very specific name to that, which is conifer. So they're all evergreens and they're all conifers because they are all always green and they always have cones, which are also 2 names of towns in Colorado. There's Evergreen and Conifer, both in the mountains, just if you were curious where those names came from. Okay, so the differences between evergreens and other types of trees, which we call deciduous, there's a very specific reason why they have these needles year-round. They have a different advantage than deciduous trees. So if we look at, follow me. This is our deciduous tree leaf, and this is our evergreen. So the differences between these, as you can see, these are shorter, much thinner, and these are fat and have a large surface area, right? So one of the advantages, or I guess one of the disadvantages to being an evergreen is that your surface area where you conduct photosynthesis is much smaller. So this has a much higher photosynthesis capability than this one does. This leaf can go through the process of photosynthesis at a larger rate than a single needle can. So that's one of the disadvantages. But one of the advantages is that these guys never lose their needles, which means when these guys lose their needle or their leaves in the fall, they have to expend an enormous amount of energy in the spring to grow them back. Evergreens don't have to do that, so they conserve their energy by not having to drop their needles, and they're not necessarily doing as much photosynthesis in the winter, but they can continue to do photosynthesis through the winter, whereas deciduous trees cannot. And then the last point that I wanted to make was last year we had a great day for it because it actually snowed for this tour, and so you could actually see this. But if you guys think of an evergreen with a bunch of snow on it, the snow doesn't really weigh down the leaves very much because there's not a lot of surface area for it to attach to and sit on top of. So evergreen needles can shed snow really easily. Deciduous trees, if you have a big spring snowstorm and deciduous trees have already started to grow back their leaves, it weighs them down and can even break the branches. And so deciduous trees really can't shed snow. It stays sitting on top of this large surface area that they have on the leaves. So those are the primary advantages and disadvantages between deciduous and evergreen trees. Okay, so moving on to 9, 10, and 11, this area about location of these trees and limiting factors. So if you're looking around the Denver area or the plains of Colorado, you do see quite a few evergreens present, whether it's pine trees, spruce trees, or fir trees, but that's not really natural. What's natural for the plains of Colorado is what you see in the east, which is primarily grassland. So where we find our evergreens in Colorado naturally is actually up there in those snowy peaks in the mountains. And there's a very specific reason for that, because if you think about, if you were starting in Denver, you hop on I-70 and you're driving up to the mountains, there's two climatic differences that really make a difference for the environment that evergreens prefer. So imagine you're driving up to the mountains, into the snowy areas over there. What automatically happens as you get higher in elevation? You get colder. So there's much colder temperatures up there, which you can very visibly see right now because there's still snow up there. And then the other climatic difference that's very important for evergreens is also the snow. So the mountains actually get a significant difference in precipitation. So they get a lot more precipitation. In fact, one of the areas of highest precipitation in Colorado is in the mountains, and it gets somewhere, I think it's above 50 inches of precipitation a year, versus one of the areas in the plains, in the eastern plains of Colorado, which gets less than 9 inches of precipitation a year. So there's a huge difference in precipitation between these two microclimates in Colorado. So evergreens, you naturally find them up there because of the colder temperatures and the increased precipitation. So then for 10 and 11, what we're talking about is limiting factors. So limiting factor, if you recall from Dr. Hammond's lecture, is something that limits or constrains a population's ability to grow or exist even. And so naturally we find these evergreens up in the mountains because of the precipitation and the temperature. One of the reasons we don't find them in the plains, as I just described, the limiting factor would be the precipitation, because we don't see as much precipitation on the plains that the evergreens need to survive. And then if we have any hikers in our class, I like to hike, Chris likes to hike, if you hike 14ers, or even if you just get high up enough in elevation, eventually you're going to hit the tree line, or the point where you don't really have trees existing anymore. That would be the snowy peaks that we can see right now without trees. And so the reason that we don't have trees above this tree line or in the alpine tundra climate environment is because there's another limiting factor that's preventing them, and it's basically the reason why there's still snow up there right now. It's our temperature. So once you get high enough in elevation, your temperature gets too cold to melt the snow into precipitation or water that the trees can actually take up.